Do you have any doubt in this graph running status?
No, sir.
No. Okay. Next, we are going to see about the DML. DML, it stands for Data Manipulation Language. It is the inbuilt language which is used by Ab Initio to process the data, to actually read and transform the data. Ab Initio uses DML at every places to read a data, to transform a data, to store data everywhere. It's a powerful language like C and C++. We have conditional constructs, we can declare variables, we can have loops, we can do everything in this DML language. And the DML fields, we can create as pixel length fields and delimiter length fields. I will give you a sample DML. So going to then, what are the different types of data types? What are different data types available in this DML? You see, the base types include string, integer, real, decimal, void, date, and date type. You know all these basic types, right?
I don't know. Real, void, and that's it.
Okay.
Real.
Void is nothing but the null data, as in the C language itself. And real, it's whole number, right, including both integer and decimals. It's actually a broader perspective.
Okay.
Normally we will use string, integer, decimal in your vector types and record types, date types also. We don't normally use real or union in practical scenarios.
Okay.
And compound types, you have record, vector, and union. This is the basic syntax of a DML. A record and end would be the starting and end point for the DML. Within those record and end construct, we need to give all our fields with their data types. I will give you a sample DML. This is a sample DML used to describe the data present here. I have an input file which is having an employee ID, first name of the employee, and the last name of the employee in a file.
Okay.
I'm going to read the data through Ab Initio using the DML which is given here. For the first 4 characters, I'm specifying like it is the ID of the employee. So go Ab Initio, take the value as ID, which is of the type decimal. And for the next characters up to comma, you can take it as first name, which is of the type string. And until you get the new line character, it is going to be the last name, which is also the type of string. So using this DML, try to read the data which is present in the input file. Are you clear?
Okay. Yes.
Okay. If you see the input data here, we have 4 digits that will be taken as ID, and up to the first comma it will be first name, and we have a new line character here. Up to that will be taken as the last name. Once you have reached the last name in the new line character, the next record will be read, and so on.
Okay.
This will, right?
Yes.
Okay. Moving on to the next slide. Where do you give your DML? Where do you provide your DML in all the components? If you can see from the screenshot, I'm having an input table component and the properties window open for that. There are many tabs as you can see: description, access, parameters, layout and ports. There is this ports component, right? Ports tab, right? In that,
Yeah.
if you see, we have different options to provide the DML. This is the place where we need to provide the DML which is used by the particular component to process the data. Okay?
Okay.
Yeah. I will tell you what are the different ways by which we can create the DML. For database components, we can generate the DML from the database itself. We will be having a generate button which we can use to create the DML from the database, and we can create the DML manually by editing in the space modes.
Okay.
The other process is we can use the Unix command to generate the DML for the database components.
Okay.
I will show you the DML page once again. Here you can see this is the one which I am talking about, embedded, right? We can directly manually enter the DML here as it is shown here.
Okay.
That's it. And to the right of it, if you see, there are validate buttons, generate buttons and edit buttons. Edit, you can copy the DML and cut and paste it. These things you can do. And using generate, this generate button is available only for database components, where we can generate the DML for the tables. And validate, it's used to validate the syntax of the DML.
Okay.
There are other three options: propagate from neighbors, streamers and path. If you have your DML created in a file, and if you want to use the DML file here, you can directly go ahead and click the path option here, and you can select browse, where we can select the DML path and give it here. The other two options will come into play when you have other components in your graph. You can directly propagate the DML from the neighboring components, or you can use the DML which is specified in the other components in the graph. Neighboring components in the sense to the left and to the right of the current component. You can propagate the DML from them. And the other option, same as, you can directly choose the DML from the other components which are specified in the graph. Through these four ways, you can specify the DML in the course window. Do you have any doubts in this?
No.
Okay. Next we are going to see what is an exceptor is. Exceptor is nothing but the transform function which you write to transform the data. Same like the DML, we can store our transform function with the file name extension .xfr, and we can reuse it in other components or other graphs. This is sample transformation. Suppose you have an input file with the following fields: in the top one, ID, your joining date, your first name and last name. And I'm gonna transform this data into ID, name and the join date. See what's the transformation I have done closely?
Yeah.
First field is ID, second one is a name column, which is a concatenation of first name and last name, and we have the join date moved to the last. Okay?
Okay.
Yeah, this is a sample transform. See how the input data is transformed according to the transform. I will move on to the next slide.
Sorry, Karthik.
Yeah, yes.
No, you asked me something.
No, I will move on to the next slide.
Yeah, sure.
Okay. Please stop me if you have any doubts, okay?
Yeah, sure.
Okay. And we have the file types. We have two different files in Abinitio, a serial file or a multi-file. As shown in the diagram here, a serial file will be shown like this and a multi-file will be shown like this. You can see from the ED display window outside.
Yeah.
What's a serial file? A serial file in Abinitio, it refers to the non-parallel flat file. Just a flat file which can hold records, can be read using a DFL. Once a multi-file, it's a parallel file, can work in the parallel layout. Actually, a multi-file is composed of different flat files which are organized as partitions, and each multi-file has a control file and the data partitions. The control file will be having the locations of all the data files, that is the data partitions, and those data partitions can reside on different hosts or different servers, thereby enabling parallelism, which is the powerful concept in Abinitio. Imagine like if we are having 4 different types of partitions and those 4 different files execute at the same time machine. If we are having 2000 records, those records are partitions of a single file. In those 2000 records, imagine like we have 1000 records and each partition has 250 records. Okay. If we are going to read through a serial file, then it will read one by one from the starting to 1000 records. If we are having a multi-file with 4 partitions and each partition is having 250 records, and each 250 record will be read at the same time. If it is a 4-way partition, then at a time we are going to read 4 records. Then the processing power will be increased. And consider the same case if you have the different partitions in different machines. So the processing power will be tremendously increased because we are combining the processing power of the other machines also.
Okay.
The parallelism concept is the important concept in Abinitio. It actually increases the processing power of a graph. Okay. The next slide. Abinitio can process data in parallel runtime environment. You know what's the parallelism, right? Parallelism concept?
Not totally.
Okay. Simply put, a parallelism is doing more number of tasks at one time. Abinitio actually supports three types of parallelism: component parallelism, pipeline parallelism, and data parallelism. I will explain you one by one. Component parallelism. Component parallelism in Abinitio occurs when a component is executing simultaneously on different branches of a graph. I will show you in an example. Consider the graph. We have two input flows, customers and transactions, and we have two sort components which are then joined to get a single output file. If you can see, we have two different flows, and if we execute this in a graph, these two files will be read simultaneously. This sorting component, right?
Yeah.
These two components will work parallelly, running on both customer data as well as the transaction data. This is called component parallelism.
Okay.
You can see this when you are executing the graph in the GDE. Okay?
Okay.
Actually, normally GDE assigns whatever parallelism it can according to the graph. So we don't need to worry about which parallelism to choose.
Okay.
These two components will be executing at the same time. See, the more number of branches in a graph, the greater the component parallelism. If a graph has only one branch, then obviously a component parallelism does not occur.
Okay.
And the next one is pipeline parallelism. It will happen when different components in the same branch execute simultaneously. Consider this example, which is reading the customer data, and we are filtering the data into two different output files. Okay?
Okay.
In this, since it is having a single branch, we can't expect component parallelism to occur, but we can expect pipeline parallelism depending on the components. Its core, actually it is a deformed component. When it is processing the 100th record, the previous records would have been processed by the filter by expression component at the same time. Okay? If you are getting 100 records and there are more records from the input file. Suppose if the input file has 200 records, while the input file is reading the 150th record, the 100th record might have been passed to the filter by expression and it would have been stored in a good customer or other customer. You cannot visualize if the data has small number of records, but imagine like if you have some 1 million records which are reading from a database or a file, you can visualize the pipeline parallelism which is happening in the branch. And this pipeline parallelism has a trick, like if a component expects all the input data to be in the buffer rather than executing at the pipeline, then the pipeline parallelism cannot happen. Consider the sort component. For sorting, we need all the data, right, to sort the data.
Yes. Yes.
In that case, pipeline parallelism cannot occur. That's mentioned here. Sort is actually an expensive component and it blocks pipeline parallelism. So you should use sort component judiciously. The next type of parallelism we have data parallelism. It's going to occur when you have a graph that has multiple divisions, allowing multiple components to operate on the different partitions of data. All will process the data simultaneously. Data parallelism is going to happen only if you are having a multi-file environment. I have previously said like a multi-file is composed of different partitions.
Yeah.
If you have different components working on data, then you will get data parallelism. See the graph which is at the below, a multi-file, a sort component, a roll-up, and then an output multi-file. Here the multi-file has 3 partitions as shown in the layout of the component. Here number 3 is shown, right?
Yeah.
That denotes the number of partitions available in the particular component. So if you run this graph, a sort component will be divided into 3 instances, and those 3 instances will act individually upon the 3 available partitions simultaneously. So we will be getting a data parallelism here. 3 partitions of data, they will be processed individually and simultaneously. We don't need to wait for one partition of data to finish and then start the other partition. The components can act on individual data partitions simultaneously. This is the processing power of a multi-file compared to a serial file.
Okay.
You are clear about the 3 parallelism techniques?
Yes.
Okay. Next, we have the layout. What's the layout? Layout, it determines the location of a resource. It can be either serial or parallel layout. It's used to specify where your component is located and how your component is going to execute in the graph. If your dataset is located at a single place, you will use a serial layout. If your dataset is located on different machines, and you need to use a parallel layout. Layout where you will give in all the components properties, there's a layout tab. Here we need to give the layout. Actually we have different options for giving your layout. We can propagate from neighbor. We can use other components layout. We can have a URL which corresponds to a serial or parallel layout. We can use the custom layout which is created by us, or we can use the host name if we can directly. These are the available layouts. Ports. A port is a connection point for the component through which a data can enter or exit from the component. Every port has an associated DML that defines the DML of the data.
Okay.
There are different types of ports across different components. Common ports are input and output port, a reject port where you will get the rejection record, an error port where you will get the error records, a log port where you can find the log information, unused port through which you can get the unused records. I will explain all the ports in the future sessions with the components.
Okay.
First one is flows. Flows, they are actually used to connect the ports. Again, the components. There are 4 different flows that can occur in an Ab Initio graph, and the symbols that denote them. A straight flow, a pane flow, a fan out flow, and an all-to-all flow. I will explain you one by one. Straight flows, they connect the components that have the same number of partitions with the same depth of parallelism. So this, if the components are serial, the flow is serial. The components are parallel, the flow has the same depth of parallelism as the component. A straight flow is indicated by a straight arrow from the component to the other component. Okay?
Okay.
Next one is pane flow. As you see the difference in the GDE display, where we are having its flow footed arrow, it is specifying like this left side component has more number of partitions than the right side component, so that actually we are gathering all the data here and putting it to the output here. Pane flows, we connect components with large number of partitions to small number of partitions. It follows the many-to-one function. We will commonly use the pane flow in departition components, where we are going to departition the data and make it a serial layout. Next is fan out flow. This is used in partition components, where we are going to divide the data into different flows. It follows the one-to-many pattern. As you can see from here, the component in the left has less number of partitions. The component in the right, it has many number of partitions.
Okay.
And the next one we have all-to-all flow. It normally connects a components with different number of partitions. Data from any partition can be sent to any partition in the downstream component. An all-to-all flow can connect with the components with same or different degree of parallelism. Thereby, each partition in the output will be getting one partition of data from the input component. These are the 4 different flows available in Ab Initio. Normally the GDE chooses the best available flow when you are developing the graph in the GDE. Okay. Next we have some important concept, cases and checkpoints. A phase, stage of a graph that runs to completion before the start of the next phase. Where we are going to use the phase, that means we divide the graph into different phases and we utilize the different resources phase by phase. What if you have a large graph which has some 100 components, which is connected to a database and it has failed while running because of system resources? In that case, we can make the graph roll back to the previously completed phase checkpoint and we can continue the graph from there. Normally, this phase and checkpoints will be used in the error recovery of a graph or a plan. If one phase is completed, then the component writes temporary file information and begins the next phase. If your first phase is running, then the components after the phase they read the temporary files to begin the next phase. If you have completed a checkpoint, then the temporary files will be deleted before the checkpoint, so that after error recovery we can continue from the place where we have the last saved checkpoint. This is actually phase and checkpoint window. We can increase or decrease the phases. I will explain through the graph how a phase works.
Okay.
Checkpoint toggle is denoted by C. See, as the execution of graph successfully passes each checkpoint, the co-op will delete the information preceding to the checkpoint and it commits the system for all phases since the preceding checkpoint. See here, a blue line indicates the phases, blue checkboxes here. Here actually they are doing a transformation with input file and the ring forward component and storing the data in the output file. And every component is at phase 0. That means every component will start at the same time when you click the F5 button. Okay?
Okay.
Okay. In that case, we are getting an error like the output file which we have given here. We are trying to read from the output file. Since every component is beginning at the same time, there will not be any data in the output file. So we cannot read that output file in the same phase. For these types of errors, we need to increase the phase of the output file component here to 1. In that case, the GD will be executed successfully. When you execute the graph, these components at the 0th phase will be executed first, then only the phase 1 starts. Are you clear?
Yes, yes.
Okay.
Got it.
We have the built-in debugger in Ab Initio, which used to debug the Ab Initio graphs or plans. We have different icons here, enabling debugger, adding watcher file, isolating components, and remove all watchers. I will explain you what a watcher is, how we are going to use a watcher. Anyone, do you have any experience in other ETL tools like Informatica or Data Stage?
No, Karthik.
Okay, that's not a problem. The watcher, it's like a simple placeholder for storing the intermediate data in a flow, and we can actually view the data for our debugging purposes. You see in the picture here, it's actually a square shaped thing that is in the flow of the Ab Initio component. It's used to check the intermediate data between two components. We can directly insert a watcher between any two type of component, and we can view the data that is going to be other component. We are going to add a watcher. In the first window, you need to enable the debugging capacity, and you need to click on here after clicking the correct way, so that a watcher will be added to the place. Otherwise, you can directly select the flow and right click the flow, choose add watcher on flow from the pop-up menu. That way you can create a watcher here. You are getting me? How we are going to add a watcher here? Use the flow, right?
Yes.
If you right click the flow, then you will get a menu. There you can add the watcher directly.
Okay.
Or else you can go to the debugging tool window. You need to click add watcher here. Both will do the same thing. You can get the watches. So where we are going to use these watches? I have already said you only the dataset components has got the option to view the data, correct?
Yeah.
We cannot view the data in the other components.
Program components.
Suppose if we have other this component, like if we have another 2 or 3 processing components and we want to see the data after the reformat fields, we need to include a watcher here so that we can view the data.
Okay.
And you will see some two simple components. We are all done with the theory, I guess. Okay. Generate records. Actually, it's a simple component. We can generate a specified number of records with our specified DML. Normally, we will use generate records for testing purpose to generate your first graph. Like this, you can say. We can control what a generate records components will generate. Whatever fields which you will give, that will generate the test data for you. See here a generate record components with the properties window. There are 2 parameters for generate records component, as you can see through the screen, num_records and command line. If you want 10 records to be generated, just give 10 in the as the value for num_records and specify the DML in the quotes. See, there is an interesting thing in the graph view. There are yellow color highlights right here.
Yeah.
This is the first time that you are taking a component into a graph and you have not specified any values for the required parameters in the graph. If you have specified all the parameters correctly, then this yellow symbol will be gone and you can validate the graph. Okay?
Okay.
If you are missing something in the component, then GDE will indicate that using this highlighting yellow buttons so that we can understand, like, oh boy, I missed something, and then we have to provide all the necessary details. Okay?
Okay.
Let's turn through an example. Consider I'm going to give the following DML in the quotes. So the generate records will be generating 5 records according to this DML. Okay?
Okay.
And I'm going to give the command line parameter as this thing. Actually, this command line parameter is optional. If you want to customize the input testing data, you can use this, otherwise you can leave it. If you are not giving the command line parameter at all, a random 10-digit decimal will be there for customer ID, random 20 alphanumeric characters, and 4 integer digits for state code, and a string value for prefer. It will come like a random value. If you want to customize it, you can have the command line parameter with different option tags. We can make the customer ID start from 35,000 and your state code can be 1 to 50, and we are making the preferred expression as well as the customer greeting to dear value to customer. We can actually customize the input data If you don't want to customize the data, just give the codes and give the number of records, then you will be good.
Okay.
This is the values it is generating for the output data. If we give the command line parameter. Next one is a trash component. We use the trash component to end the data flow in the Ab Initio graph. Just like we don't need to have the data anymore. In that cases, we can use the trash component to end the data flow. Trash accepts all the input and ends the data flow. Discards them. If you are testing any graph means, we can actually use a trash component with the voucher content to it, so that we can view the data as well as discard the data for our temporary purpose. Okay?
Okay.
Okay. We have some case studies to work on today. I thought like today we will have the software so that we can work on that. Unfortunately, we are not having the software today. I'm hoping like we can get the software tomorrow.
Yeah.
Got this.
Even I'll ask them
Okay.
to provide the software.
Yeah. Tell me, Suman, if you have any doubts up to this session. You got the basic idea, right? How these two components work?
Yeah. How got it?
Okay. Once we get the GDE, hopefully we can work on that.
Okay.
Okay. Shall we continue?
Yeah, sure, Karthik. Even I'll ask them to provide the GD as soon as possible.
Okay. They said like they'll provide the GDE tomorrow.
Okay.
So that we can work on this case study, right?
Yeah.
It's like we need to create DMLs and using generate records, use the DML, create 10 records and send the records to track.
Okay.
Okay, I will get to the next slide.
Yeah.
Component organizer, that's the placeholder for different components that are used by Ab Initio components. Component organizer is organized into, categorized into different folders that's having related components. Actually, we can get a small description of the component in the component organizer itself, what a component is doing. To get the component organizer, you can choose the shortcut F9, or from the menu bar, you can choose View Component Organizer. See how a component organizer displays here. We have selected a sort component in the window, and that displays the short description of the sort component, right? How does your data appear in the specifier? We can get a small info in the organizer itself. These are the different categories available in the component organizer. Administrative database, dataset, miscellaneous partitioning, sort, XML, everything. I will explain you all the components which we use practically in the future slides. First, we'll see the dataset components. One second. Okay, so we will now see the dataset components.
Okay.
Are you able to see my screen?
Yeah, I'm able to see.
Okay. First, the input file component. Input file component is located in the dataset folder. An input file is used to read the input data in a graph. You can use an input file component to read a serial file or from a multi-file. We have to specify where the input file is located along with this absolute path and the DML to read the data. Okay?
Okay.
Let's see how an input file looks like in the window. This is the input file component which is located in the component organizer. We have different tabs assigned to it. The description tab, access tab, parameters and ports. We can specify what DML which we are going to use in the ports window. I have explained all this to you already.
Yeah.
This is the record format editor shown in the grid view where we can view our DML. See, as I have already told you, dataset components, they have got this view data option in the right click menu. See the view data option here, and there are different options also. You can cut and paste the component in the other places in the graph. We can validate the component here. You can disable or enable the component. We can directly go to the help window, or we can open the properties window from here. Okay. What data can be displayed? We can display both fixed and variable types. All the supported types like strings, numbers, decimals, date formats, everything is supported. You can also provide complex data types. Okay, here we go with the attributes pane in the record format editor. Suppose we have got a date field and we want to specify what is the date format needs. In the grid view editor, you need to go to the attributes pane as shown here, where you can select. After you click this attribute pane, the attribute windows will be open where you can select the format for the data. For each data type, there will be different attributes, so we can select the attributes of your choice. Next is an output file. An output file is used to store the output data in a graph. It can be serial or a multi-file. It's same like the input file with the path and DML we have to provide. See the output file description tab. We need to specify the path in the URL window here. And actually we can switch it to an input file or lookup file or an intermediate file through these four options. If you select input in this option and click OK, then this file will become an input file with this port transformed to this side. If your port is in the left side, then it's an output file. If your port is in the left side, right side, then it's an input file.
Okay.
Here you go with the access tab. There are different file handling options here for the output file. What if you have your output file already created, and if you want to Append to the file means we have to select this option, append output to the end of the file when writing. If you have the same file,
Okay.
you want to delete the file means you can select this option. Normally this two will be selected. That is, every time you run the graph, a new file will be created, deleting the older file. If the file is not there, then a new file will be created, and you can set the file permissions in the Unix. What are the file permissions for the user group and others? You can set the permissions here, read, write and execute permissions for the output file. The things to be explained here, and there is another one thing, like don't roll back with the job files. If you click this option, then whatever contents are written to the output file up to the error of the graph, that contents will be stored in the output file. Next, you got this codes window. I have explained this. Okay, now we are going to select a file which is stored already. In that case, we are going to click the browse icon here, and we are going to select the file selected.dat in our working folder. This way we can configure our dataset to use this input file. Next one is an intermediate file. So I'm hearing some background noises.
Yeah, that's what some work is working. I close some Is that fine now?
Okay. Yeah, yes. Okay, we'll continue with an intermediate file. An intermediate file is, it has two ports actually, an input port as well as an output port. It accepts the input data and copies the data to its output port. It is used to get the intermediate records. We can store the data to the intermediate results, and we can view the data to the input file. Same as the other file components, we need to specify the DML as well as the path of the data. Actually, when you insert an intermediate file, normally a separate phase will be started, because through the input port, the intermediate file accepts the input and stores the data. Then in the next phase, it starts to read from the intermediate file and passes the data to the output port.
Okay.
So when you are inserting an intermediate file in a graph, the components to the left of the intermediate file will be having a phase 0, and to the right of the intermediate file they will be having phase 1, including the intermediate file.
Okay, even intermediate file will come to first phase then.
Yes, correct.
Okay.
Next one is a lookup file. Lookup file represents one or more serial files or a multiple of data that we are going to be used as a lookup, which is as small that can be stored in the main memory. Where we are going to use the lookup means, suppose consider an employee file with the employee details, and we have the employee's location details in another data file. We want to get the location of the input file from the data file which is having the location data. Basically, we want to do a lookup kind of thing to get the data from the location file through your employee ID. In that case, we'll use a lookup file in our graph. See, there's an example graph with an input file. We are having a lookup file in the graph. We are looking up the data through the input file here, and we are storing the output file. The normal recommendation is to store the lookup file at paste 0, since that will be validated at the start of the graph. You can always choose an output file to be used as a lookup file in the later stages of the graph. I will explain you how we are going to do this.
Okay.
Lookup file, in addition to the file as well as DML, it has got the parameter key, so that based on the key we can do the lookup. We need to specify the key for the lookup file we are generating. Okay, an example lookup here. We got this input data, ID, name, city and amount, and we have the data of joining for the employees in a lookup file like this, and we want to get the DOJ, data of joining, from the lookup file, and we need to get the output data like this, ID, city, amount and data of joining. We don't have this in the input file, right? We are going to get the data from the lookup file here.
Okay.
Through this transform function. Actually, this is a reformat function where we can use the lookup. We are transforming the output ID as the same as input ID, city and amount as the same fields.
Okay.
For data of joining, we are pointing to the lookup file through your ID key and getting the data of joining field. The lookup syntax is lookup of, lookup file name, lookup key, and what is the field you are getting from the lookup file. As there are two other fields in the lookup file, we can get an ID or a data of joining field through the employee ID field here. You give like this for the first record ID, it will compare all the records in the lookup file. If you get a match, then it will retrieve the matching data of joining value. If there is no match, then the lookup will return a null value.
Okay.
Lookup, and what if there are multiple values in the lookup? Suppose you have an employee ID called 100 in input data, and you have two records for the data in the lookup file, like 100 and June 22nd, 100 and June 23. If you have duplicate values in the lookup always takes the first value.
Okay.
It will always retrieve the first value, then it will search for the next record. If there is no match found, then the lookup returns null.
Okay, the value will become just null. The date column will populate as null.
Yes, correct.
Okay.
And in that cases, you need to make your output field as nullable so that it can accept null from the lookup. Otherwise, your transform is going to throw an error like this field cannot accept null values.
Okay.
You need to write your transform like, if you are getting a null from this, then what I need to do? You need to override the transform here that we will see in the reformer component class. For sake of purpose,
in that case we can use output TML DOJ equal to null, right? Then it will become as nullable field.
Yes, you are absolutely right.
Okay, if we don't use that, it will throw the error, like null is coming, but this is not a nullable field. in like that.
Yes, you are right.
Okay.
That is one way. If you want to populate a default value for that, we can always override the function to check if it is returning null, and we can populate the default value. I will explain you when I am explaining the reformat component. Then that will be more relevant to you.
Okay, sure.
How will you convert an output file into a lookup file? You can convert an output file generated in one phase to a lookup file used in a later phase. To achieve this, go to the description window of the output file and check the Add to Catalog button. I will show you how. If you see the output file tab here, there is a button called Add to Catalog, right?
Yeah, Add to Catalog.
If you click on this, then this output file component can be used as a lookup in the later stages of the graph. Okay?
Okay.
If you select the Add to Catalog button.
Okay.
Yeah, go ahead.
No, I'm just asking. Lookup is there, no? If you just click on lookup also, it will act as lookup.
Yes, it will change it to a lookup file.
Okay, then what is the difference? Add to catalog and
Yeah, in that case, the lookup file is already created and we are going to point to a lookup file which is already in our file system. This is an output file which is going to be created in this graph, and I am going to use the graph as a lookup file in my later process. You got the difference?
Yeah. Okay.
If you click on this Add to Catalog, and the additional parameter called key will be included automatically. See here, after you click on Add to Catalog, then this parameter window is displayed as a yellow highlight because you need to specify the key, right?
Okay, yeah.
So, I will show you the difference in the previous window. See, there is no yellow color highlight in the parameters because it is an output file. So click on Add to Catalog. Still it's an output file, but it can be used as a lookup. Still it's an output file, but can be used as a lookup. So that we need to specify the key here. You got the difference?
Yes, got it.
Okay. And next we have an ad hoc multi-file. Actually, an ad hoc multi-file, you can derive it from the serial file. It's used to hold multiple partitions, but it's not a multi-file. Like it is having a control partition and data partition. It has no control partitions, but it has different partitions that can be accessed through a serial file. How we are going to convert a serial file into an ad hoc multi-file is we need to specify different partitions in the partitions tab instead of the URL. Actually, the different serial files which you are trying to read at the same time, they need to have the same DML so that we can pick up the serial files as data partitions at a single time. We can read some different files using the ad hoc multi-file. How we are going to define an ad hoc multi-file? Instead of the URL option in the data tab, you need to check the partitions tab. After you click edit, this define multiple partitions window will open.
Okay.
Here you can specify the different partitions one by one. Each line will be counted as a single partition. Okay. If you are having 4 partitions like sales1.dat, sales2.dat, sales3.dat, and sales4.dat, we can normally give all the file names one by one here.
Okay.
The 4 files will be read at the single time using the DML specified. Remember, the DML must be same for all the data partitions, and ad hoc multifile is useful when you are having different files with the same DML and you want to read it at the same time. Okay?
Okay.
You can also employ the wildcards as in Unix, the star, as well as suppose you have sales data for different dates monthly or sales data daily wise, and you want to read January month data. That means you have to read 31 files of the January month which is having the sales data, correct?
Okay. Yeah.
And if your file name extensions are like this, sales dot and your date appended at the last, so you will be having sales 2014 0101, and the next file sales 2014 0102, like this. You can just simply employ a wildcard star at the end. First you can select the all files. Sorry. So you can select all the files to be read as a single at the single time. I will show you with an example here. See here, instead of using the URL tab, we are using the partitions, and we have given the absolute path as well as a wildcard to read the data partitions. Read mul readmul star.dat. So we are going to read all the files which are starting with these characters and ending with .dat. Okay?
Okay.
If you read all the files like read mul 1, 2 or any characters in between and the star.dat.
Okay.
You can read all the files at the single time. Okay?
Okay. Okay.
Next is a read multi-files component, which we can use to read multiple files. That means multiple serial files. It reads the input records, gets the file name from one, and records from each file. Each individual file is passed sequentially to the output port. We have different parameters for the input files, like where we need to start the input data reading, how many rows we want to skip, where we are having the header, what if a file name is not present, what if a file is throwing error. We can set numerous options for the read multiple files.
Okay.
These are the different parameters which are in the read multiple files. And we have an optional transform also. We can use to file names and read the file. We have a filter to filter the records. I will show you with an example here. I'll show you with the example in the GD. I don't have a slide for this.
Okay, sure.
Okay. Next, of dataset component is write multi-files. Same like the read multi-files component, we can write multiple files as the output. It reads the input records, it gets the file name from each input record and passes all the records to its output port. We customize the transform function, same like read multiple files to skip records, to filter records, and how we are going to write in the output file. We can customize all these. So the basic usage is to read multiple files. We need read multiple files component. To write multiple files, we use this write multiple files component. Same like the other parameters. We have transform. We use the transform to get the file name and the optional transform. We can also use the compress to compress the output. As an example here, we are combining two input flows using join, and we are writing multiple files. We are getting the employee info, and we are going to generate employee files city wise. So the output will be the employees who are working in a particular city will be stored in a particular file. Okay. So if we have 10 employees whose city field is Chennai, then that 10 records will be stored in Chennai file, and the other records will be stored in other city names files. Are you clear?
Okay. Yeah,
We need to
okay.
specify the transform like this. For the file name, actually we have given the path as well as the incoming field name, city field, so that if there is a Chennai record in the field, then a Chennai.dat file will be created in the output.
Okay.
And we are writing all the records, corresponding records to that output files. I'll explain this graph once we get the GDE.
Okay, sure.
We will see the database components. One second. Okay. I think it's 10:30. Can we close the
Yeah,
session
it's-
today?
Yeah, sure, Karthik. We'll start from tomorrow.
Okay. What time you want to start? 8:30 a.m.?
Yeah, sure. By 8:30 we'll start, Karthik.
Okay, sure. Just inform the organizer like we are starting the session at 8:30, so they will
Okay.
start the meeting.
Yeah, meeting session.
Okay.
Okay,
Do you
sure.
have any
Karthik.
doubts on the dataset components, file components?
That's it, but read multiple files and write multiple files video, and if we see it in GDE and if we work.
Okay. I got that.
All other dataset components are fine, but these two I didn't get that.
Okay. I will explain it with examples.
Understood the
Okay.
yeah, concept I understood, what is the purpose and all, but if you
Yes,
just
yes.
do it in GDE practically, will come to me.
Yes, I understand. I will explain it through examples. Don't worry. And how
Sure,
to
sure.
create a lookup file, how to use the generate record components.
Yeah, that and all I got it.
Okay, Sanu. Then I will see you tomorrow at 8:30 a.m.
Sure, Karthik.
Okay.
We'll start
Okay.
at 8:30.
Okay. Okay. Thank you. Bye bye.
Thank you. Bye.